Hello and welcome again. My name is Łukasz Łukowski. I'm representing STORDIS, and together with me there are two of my colleagues from Pluribus. Before I will let you introduce yourself, gentlemen, let me maybe tell a little bit more about what we will try to discuss today. So at Pluribus, there was definitely some exciting news happening lately. So in fact, this is our second webinar, but with those nice changes and a closest cooperation with NVIDIA, definitely we needed to set up another one. So Andreas, Manuel, once again, thank you for joining. Thank you for taking the lead today over today's meeting, and voice to you. Andy, maybe starting from you.
Right. Well, thank you. Thanks, Lucas. Good to be back. Good to be back on stage with you here. My name is Andy Falkner. I'm heading up the Pluribus team in Europe, in the EMEA. And, sales never comes on its own, because what would good sales be without an engineer? And let me introduce Manuel. Manuel, over to you first.
Hi, thank you, Andy. Hi, Lucas, and thank you for inviting us today. So, my name is Manuel Guerrero, and I am System Engineer for Pluribus Networks in the EMEA region. Thank you.
Perfect. Agenda for today, cloud networking mandates, unified cloud networking vision, the most important, extending the unified cloud fabric to the server with NVIDIA. This is the point of our meeting. Summary with the Q&A. Like always, please feel free to ask any questions. We will try to answer that in the end of our meeting.
Right. And this is what we're in for. Shall I take over, Lucas, right?
Yes, please, feel free.
So yeah, it's all around cloud networking. And there's obviously a lot of buzz. There's a lot of hype around cloud networking. And if you ask different vendors, different players in the market, you'll always get different nuances of the answers. Hopefully, these nuances all lead to the right direction. But at the end of the day, the cloud is been separated in two main blocks, as you know, the public and the private cloud. While the public cloud, the AWSs, the Azures and Googles, they will remain and they will grow, and they have like their own benefits and use cases. Still, a lot of workloads will remain in the private environments. Customers, because of proximity, because of legal reasons, will have to make sure they'll maintain their own data centers. And this is what we're scoping up today. We're looking into these 75% of the workloads, which will have to remain in a private, hence a customer data center. Now, if we basically take a look at who are the users of the cloud, of the private cloud, we'll see that it's obviously a broad range of players, telcos, hosters. We're talking about campus cloud. We're talking about metro edge. So we have different use cases going along. But what all of those have in common, obviously, in order to kind of spin up a workload, spin up a process, spin up a service, you need to be fast. It doesn't help you if it takes you 2 weeks or 3 weeks to provision a VLAN or to set up a firewall instance. So you need to have that speed, which definitely the public cloud administrators are showing. So the same counts for the private. Then there's a cost factor to it. And most important, people can't wait for their applications to run. So the latency and the user experience is a dominant factor going along. Now, but this all has a challenge. And the challenge, we'll have to admit, is all around the network. It's all around the complexity. And networking per se is complex. Many vendors, many standards, interoperability is complex. And now resiliency gets complex. So the architecture itself, we'll have to take a look at it. And then once you've got it up and running, and once you understand this, you'll need to see that you need to operate, and you'll need to make sure that you're being able to maintain what you're doing. So out of all these challenges, we've identified networking is always on the topmost side. And one of the reasons why it is so complex It's because of the fragmentation. Now, we talked about public and private cloud. So the first decision is going to the 25% or going to the private cloud. Now, but if you're in the private cloud, if your decision is clear, you'll build up your own data center or your own local cloud. You're going to make it local. You're going to be responsible for it. The question is, are you going to do it by yourself or are you going to hosting it? Now, then the other question is, how do you build redundancy? Single site, multi-site. Do you make a, you'll go for a hybrid. You'll go for a hybrid design. So even the private cloud itself has decisions to make. Once you've made that decision, you'll need to see, well, you need to have a base, you need to have the hardware, you need to have the underlay. What is going to be the vendor of choice for the underlay? Multiple vendors are out there. Interoperable, most likely, but not necessarily. Everybody comes up with its own kind of benefits. And then you've got this overlay discussion because it's all in a virtualized environment. So we're not talking about physical only, we're talking about virtual workloads running on top of it. VXLAN is being the most dominant overlay technology, and we're going to show you some of that. So complex, again, fragmented, but at the end of the day, the network is just the facilitator. And at the end of the day, you'll have your storage, your service devices, you've got your security devices, right? Which you all need to build together. And talking about virtualized environments, well, which hypervisor are you using? VMware, OpenStack, Kubernetes. So if you pull this all together, super complex, super fragmented, and the challenge here is unifying, simplifying, securing that it's gonna work. And this is what we are aiming for, and this is what Pluribus is standing for. Now, what are the mandates? Obviously, the network infrastructure has to be agile, simple. We'll have to have the bandwidth. We'll have to move at speed. And we'll have to make sure that these proprietary solutions are going to be broken up, that we're getting out of these fragmented environment. And as everything is going to be distributed these days, we're distributing the architectures between multiple sites, between public and private. I talked about this. You'll have to make sure that you're not losing the security aspect going along. So you'll have to have a distributed security and the visibility architecture going along, making sure you see what's going on in your network. So these are the mandates. Now, let me introduce Pluribus Networks. This is kind of setting the stage. We are a software-defined cloud networking company aiming to simplify the networking. We're out there for over 10 years already. We've got some world-class partnerships with Ericsson, with Dell, with EdgeCore. We're partnering with i3New as well as VMware. One of the broadest or most important technology partnership with Broadcom. So we understand how, with our partners, how the data centers, how the private clouds are being operated. We've got worldwide presence, both in sales as well as in engineering and in tax. So we've got that around-the-clock motion of supporting our customers. And over 100 of the top mobile operators already trust in our technology. So we've proven that we've got a very resilient and a very and a very stable, mature product going out there. Ericsson and all the Ericsson customers in the packet packet core are relying on Pluribus technology, and this is where we're learning, and this is where we're listening to the customers, and we're bringing it all together, going along. In a nutshell, what is our product offering? Where did we go to, and why are we sitting here today? We are one of the first ones who claimed out SDN, software-defined networking. We've been taking SDN to an appliance. We've been taking SDN to the white box, and now you'll see a good match with STORDIS. STORDIS being the open networking #1 player in Europe, and we are one of these vendors, software layers, to run an open networking hardware on EdgeCore, on Dell. So basically, you get software from us working and operating on an underlying hardware environment. But the networking side is one side, and we see that the complexity, as I alluded, the complexity of the data center mandates the next wave, and the next wave is called the smart NICs, DPUs, deep processor units. So we are already developing to bringing networking-like features and functionalities into the server. And this is what the session today will have about. So we'll talk about our standard technology, but we'll always need to remember the time is changing. We need to follow up what is mandated by the data center environment. So what is the base here? Where are we coming from, and where are we basically seeing our benefits in our sweet spots? We've been claiming on the open networking architecture, which means we're running our software on white box switches like EdgeCore and Dell, Celestica. There are other vendors out there. The biggest advantage for the customer is choice. We're giving the customer the choice and say, hey, we're not going to lock you in. Once you'll have to choose a vendor, you're always doomed to use the same one. You're able to pick and choose. And especially in today's challenging times of lead times, one has huge lead times on a 10 gig switch, 100 gig switch. Well, customers can move over. Hey, there is like an EdgeCore switch available at STORDIS. I'm going to jump on it. So we love that agility, and we're going to bring in that decision criteria as well into our discussions with the customer. The software we're running is called Netvisor. Netvisor is a Linux-based Debian operating system developed for DevOps environment. So that is kind of the base. And on top of the Linux operating system, we're running our Fabric, adaptive cloud Fabric capabilities in a very containerized fashion. So you'll basically have workloads you can add on, and we're already showing that distribution in our the distributed architecture of virtualized networking services within our architecture of the software. Low TCO, investment protection. You have the choice. These are the main advantages of open networking, and we've been super successful within that strategy, especially challenging some of the biggest incumbents here, who all kind of claim their lock-in technologies and their lock-in solutions. So open networking is the base, but now we're moving on because we're taking this open networking standard to the NIC card, hence the smart NIC. And here we're partnering up with NVIDIA. Now, this is not an exclusive partnership. NVIDIA is one of the first ones with its Bluefield offering to be able to deliver smart NICs already today for customer trials. Obviously, all the other big ones. AMD just acquired Pensando. We know that Intel is developing. Everybody has to go that way. It's always that innovation race. And NVIDIA and Pluribus together will form a perfect partnership. NVIDIA's got the hardware ready. We've got the software ready. Now, what is the beauty about it is it's basically a smart NIC sitting within the server, but like you can see, the lower green part in my little demonstration here shows that this is basically the networking part. So all the networking functions, which are basically part of the NIC card of the server, are belonging logically to the networking side going along. Now, the big advantage is we're having a lot of CPU. We've got memory. We can scale. We can reduce that complexity. And already here, and one of the benefits I'm going to elude over and over, if you talk about virtualization, you've either been on the VMware side or the non-VMware side, all right? You've been like on the OpenStack side, but VMware, and then you had to make a decision. With SmartNICs, this is over. The SmartNICs is independent of the virtualized environment running on top. Kubernetes, we've just had a super demo the other day on our Kubernetes flow tracker. VMware is going to be supported. So you've got that clear demarcation line on the SRIOV to make sure that the server is being independent from the network operations. So DevOps and NetOps are not going to get in its way. One architecture, we're taking open networking into the Bluefield. And this is how the NIC card looks like. Pluribus and NVIDIA announced a strategic partnership. We've already demonstrated feasibility going along. We've got a couple of use cases, micro-segmentation, unified SDN-automated fabrics, and very important, that visibility aspect. So we're ready today to demonstrate and to show this. And we're ready for field trials. We're ready for customers to say, go and deploy it. And this is, as we speak, already running. So whatever I'm talking about is not roadmap. It's tangible. You can even buy the Bluefield NIC cards already. So that is kind of going along. Now, the challenges we're trying to solve is it's all around. I talked about the distribution with spine leaf architectures. We've been taking the distribution into the network architecture, and now with the smart NICs, we're basically adding this on to the server, as the server and the NIC card is going to become part of the network. DPU is a super approach. DPU stands for deep packet. Deep processor unit, sorry, not packet, deep processor unit, and it's basically it provides you that clear demarcation line between NetOps and DevOps, between the compute and the networking layer, in order to make sure the services and the processes are running independently and they're not interfering each other. The challenge is, and you're going to see that solution for us, how do you combine a traditional fabric, a traditional network with switches and Netvisor running on it, and the unify and the DPUs on the server? And this is why we call our solution a unified network, a unified platform. So here are kind of some of the targets for us to kind of educate and talk to you. Now, the foundation about it all is, you'll need to understand what is the cloud fabric. The cloud fabric as a spine leaf architecture running on the hardware open networking switches. This is where it all started from. This is what we'll basically need to tell you as a fundament in order to understand the unified cloud networking strategy. So how does that look like? The advantage, or the cloud fabric, is an SDN based solution. SDN basically means that we've got a controller functionality running on the network, which is managing the underlying networking switches and playing in that overlay view. We're going to give you a short demo soon. Now, the big advantage on the Pluribus solution is that we don't per se need a physical appliance controller. For us, the controller is distributed within the SDN fabric. All of our switches are being part of that, taking part in that controller functionality. It's super important if we're going to talk about the DPUs in a minute. That is because that is a fundament. We're going to share the control and the management plane over all of our nodes, being the server smart NICs as well. And this is where basically it's simple for us to kind of take it to the next step. What SDN, distributed SDN, means, you can basically form a fabric over multiple sites. So you don't have that proximity and the limitation on a single site environment, and it's easy to integrate into heterogeneous standard technologies. So we can mix and match with third-party equipment. You don't have to rip and replace your Cisco Arista switches to run Pluribus SDN in your environment. You can seamlessly integrate it as we move along. So the first benefit and the first indication is a controllerless architecture, which is distributed and which provides you a couple of advantages. And one of the major advantages is that power of interoperability. Okay, so you'll start with a cluster with 2 switches integrated, and in order to kind of form a fabric, all our nodes, our end nodes, would need to have is IP connectivity. We need to see each other via IP, whether this is over a single switch, spine switch from a second vendor, or whether this is over the WAN via core, service providers, MPLS connection, whether it's a dark fiber in between. We don't mind, as long as we see each other. Our nodes have reachability. We can form a fabric. We are having that interoperability within the Brownfield. We don't stick to a single topology. We can use it in a mesh and a ring technology. We can use it on in the campus, in the campus core, as well as in the data center. So there is like a vast majority and broad ability of use cases we can apply going along with our fabric approach. Brownfield requesting no lock-in, so we are able to kind of move forward in an existing environment. Now, the other benefit is, and this has kind of been indicated in the slide before, is we're able to stretch the network as well. We don't have a boundary. We can have like different data centers, different of these private clouds being stitched together, or we can use it as a data center interconnect connectivity. So you'll see it logically as a single network, as a single entity, whether it's a DCI approach, whether it's a pod interconnect approach. This is the power of a controllerless architecture. And here is a nice way to basically hand it over to Manuel and give it a short run on a demo, Manuel.
Okay, thank you, Andy. Let me start sharing my screen. Good. So I just connected to one of the devices in our fabric. So for example, if I do a fabric node show, we can see how this fabric is made up of 9 different devices. They could be physical switches or servers with a SmartNIC, or simply a mix of both, right? So the important thing is that all of them are seen as a single logical entity, the fabric. So for example, we can do this. For config show, port 1. And this is returning the configuration which is applied to the port number 1 on each device which is part of the fabric. As you can see, the output shows many parameters, but our CLI is very flexible, so we can filter the output specifying only the parameters of our interest, right? So for example, I could do the following. For config show, config show port 1, and now we can specify simply the parameters where we're interested. So for example, I will say switch, port, speed, jumbo, I don't know, AutoNEC, maybe enable, and yes, why not, LSCP mode. So, and this way, the output is filtered, showing only the parameters of our interest, right? Now let's say that we want to get the output of several ports, but only on specific devices. So then we can simply do the following. We can say switch, EBC leaf 3, for example. What else? EBC leaf 4, for example. Now port config show, again, port. Now I will choose port number 1 and port number 3. Okay, and then simply we will tell again the specific parameters that we want to be displayed. So let's say switch, port, also speed, what else? Jumbo, for example. Yes, AutoNEC, if the ports are enabled or not. And also, yes, LACP mode, for example. Okay, you can see how this has been filtered, and now we are receiving only the specific parameters of these 2 ports for these devices, these specific devices, okay? Now imagine that we want to check all the parameters of a single port, but instead of having the output in a horizontal layout, which can be sometimes difficult to read, we can instruct the CLI to provide the output with a vertical layout. So to do that is as simple as saying, for example, switch, EBC leaf 2 in this case, for config show, port 1, format all, I want to see all the parameters, and now we can say, hey, show me or present me that information in a vertical layout, okay? You can see how this way it is much easier to read the specific configuration for all those parameters. Okay, this was with regards to the flexibility of our CLI. Now let's do the following. With this command, VLAN show, we can see, for example, all the VLANs that have been created in every device in the fabric. And also the same way as we were doing before, we can also filter this output. So for example, we can do a VLAN show, format, and now we'll say switch, ID, for example, VXLAN, scope, the description, which are the active ports for that VLAN. For example, untagged ports too. Okay. So as you can see, now we have, with just a single command, a very easy way to inspect all the VLANs that exist in our fabric, right? Now let's do the following. Imagine that we are interested only on some device, not in all of them. So we will just need to specify on which device we want to check that information. Just take a look. Right now, I'm connected to leaf number 2, but now I'm going to check the information on a different leaf, on a different device. So for example, I can say EBC, leaf 4, okay? And now it is providing only the information related to that specific device on the whole network. Okay? The same way, if we want to check, for example, just one specific VLAN, we could do VLAN show, ID 10, and this is telling us where this VLAN has been created in the whole fabric, okay, in all the devices in the fabric, and on which ports this VLAN is applied, okay? So this is the beauty of our solution, that it allows us to provision any object or service across the whole fabric, independently of where the devices are located. Let's now take a look at how simple it is creating, for example, a new VLAN in all the devices which are running our Netvisor OS. First, let me check, for example, if a VLAN, for example, if VLAN 230 exists. Okay, it does not, so we are going to create it. To create this VLAN across all the devices, it's as simple as doing this. VLAN create, ID, so for example, 230. Scope fabric, we want it to exist in all the devices in the fabric. Now VXLAN, we just apply, we identify the BNI that we want to assign. So for example, 1230. Ports none. Right now, I don't want that to be applied to any port. Then we just provide a description. So, for example, global VLAN 230. Okay, yes, let's spell it correctly. 230. Then auto VXLAN. This is very important, so that this way it will be applied to all the VTEPs in our fabric. And that's all. It has been created. Now let's take a look into that VLAN show ID 230. As you can see, this VLAN has been automatically created in all the devices in the fabric. Okay, now we are going to do something different. We are going to create a subnet and extend it across all the devices in our fabric. This would be the equivalent of a layer 3 VPN service. So to do this, it's also very simple. Again, subnet create, okay, scope fabric. We provide a name, so for example, subnet 230. We map again the same BNI that we used before with that VLAN, and then we simply say network, the network in this case that we want to create. So for example, 192.168.230.0/24. We specify the BRF to which we want this subnet to belong. So for example, BRF demo 1. And now we just specify the Anycast gateway IP. In this case, it could be 192. Anycast gateway IP, exactly 192.168.2.130.1. Okay, it has been created. Let's take a look into that. Subnet 230. Okay, with underscore. There it is. You can see with just one single command, we created a layer 3 VPN service. So a subnet which is distributed across all the devices in our fabric. So you see how, thanks to the high level of automation of our solution, it is very simple to configure and provision services across the whole fabric, independently of where the devices are located.
As you saw, for us, the fabric is a single unit. It's a single entity. So you don't have to kind of abstract from, oh, I've got 15 switches, nodes in the fabric, and I'll need to configure and orchestrate them all, and I need to write a script. No, it's all around a single fabric. But what about if you've got multiple users, multiple tenants, multiple customers using it? So here is where we've got like a very good solution built in our code, as we are providing multi-tenant segmentation. The control management plane and data plane are strictly separated from each other. We can apply security and user control on a per tenant basis. So only tenant red will only see his own resources. Same with tenant blue, same with tenant yellow. And we can do a traffic segmentation, security policy enforcement on a per tenant basis already on the networking scope over that entire entity of the fabric. So here is obviously a perfect cloud use case, which is absolutely dominant and important for existing customers. Now, what we've shown you and what is important is that all of these activities are being fully automated, and it's not like you'll have to do it via scripting or external tools. This is all already being built in. We're supporting REST APIs for the fabric-wide programming, and what Manuel just showed you, you'll provision a single VLAN, you'll do it once, and you don't basically have to do it on the entire switches within the fabric. You don't have to jump from, or you don't have to connect to a specific node in order to do so. This is already, as soon as you are connecting to the fabric, you've got the full power of orchestration. And we have a lot of these tools, from policies, vFlows. We can segment the network segmentation. We can use different orchestration tools. We have different operations groups. So we'll have a high degree of flexibility of built-in automation tools and capabilities already going along. And the biggest benefit is we are trying and we are eliminating errors and hence cost as well in the operations, on the operations side. So that power of operation obviously is super important going along. Now, what do you want to troubleshoot? You need to troubleshoot, and you need to see what's going on in the network. And here is yet the other benefit of our architecture and of our solution, because we have a real-time view of all the flows between all the nodes within the fabric. Fabric-wide visibility for telemetry and deep analytics purposes. You don't need additional tools, probes, or appliances. You don't need additional software going wrong. We are able to spot security concerns, denial of service attacks. We can use it for capacity planning. We can create reports. We can alert. So all of this is already available in our management tool, and this management tool is so powerful. Other vendors are using it, or there are vendors who are building their solution only around that visibility and telemetry. We as Pluribus have built that within the network, and we're able basically to demonstrate it again. And then I'm handing it over to Manuel.
Okay, so let me briefly show you Unum and Insight Analytics. Unum is our graphical user interface tool for management, monitoring, and analytics. This is Unum. As you can see, Unum is able to manage several fabrics at the same time. For example, here on the left, we can see how there exist 4 different fabrics, okay? Front, Leaves, MEFAB, and EBC VirtualWire 2. So for example, on the dashboard topology, yes, because Unum provides us several dashboards, right? So in one of them, in the topology one, it is providing us with a diagram of our network. All the devices that you can see here, all the green icons that you can see here, are devices running our Netvisor operating system. The others, those in gray, are third-party devices. So for example, these are routers running a third-party operating system, right? And here we have also some servers and some additional devices. So as you can see, everything is clickable. For example, if we make a click on any node, it is providing us different information. So for example, the model of the device, the management IP, the status of the power supplies and the fans, the amount of memory, and so on. Also, if we click on the link details button, it is showing us all the links which are up, right? So all the links to other devices. And here we can we can do a click on any of those links, on any of those ports, and we can very easily modify any parameter of those ports. So now let me very quickly show you another dashboard with the Fabric Health. With the Fabric Health dashboard, it is providing us a different, several widgets with different information. So for example, it is showing us the total amount of memory and CPU being utilized by the devices that are part of the fabric, right? Again, everything is clickable. So for example, if we make a click here, which is presenting the memory utilization of this device, it will directly bring us to the specific page showing that information on that specific node, right? Let me very quickly go back to the Fabric Health. So apart from these widgets, which are showing, as I said, the memory and the CPU utilization on each device, this dashboard is providing us also a wide variety of information. So for example, if there has been any recent warning or errors that have been issued in our fabric, right? Also, if there have been any recent commands applied into the fabric, also the number of current active endpoints, number of VLANs, VRF, very important, the number of VXLAN tunnels. So at the end, in a few words, the Fabric Health dashboard, what it's providing us is a very easy way to, with just a very quick look into this panel, to know if everything is working fine in our fabric or if there is some problem. Okay. Now let me talk very quickly about Insight Analytics. Our Insight Analytics module is taking all the TCP connections. We can select. We have a time selector. Let me select the last 40 days. Okay, this is not a very high amount of connections. Let me just very quickly move to this other fabric. I think here the number will be higher. Okay, yes. So as I was mentioning, the Insight Analytics module, what allows us is to have a comprehensive view on every single TCP connection that have traversed our network during the last 30 days, okay? So for example, here we see how within the last 30 days, there have been a total of around 50,000 TCP connections, 50,000 flows traversing our network, okay? So again, here we have a different set of widgets. For example, here we have two providing which are the top services, okay, the top connections ordered by service. So for example, we see how the SSH service is the one who caused it, or who traversed who caused it the most, the highest number of connections in the fabric, with a total of almost 15,000 connections. We have also additional widgets. For example, here we have the top clients and top servers by connections. So for example, we see how this client, the one with the IP 172.18.22.3, this one had almost a little bit more than the 17% of the total amount of connections in the fabric, right? As I said, everything is clickable. So for example, if now we make a click here, it will drill down all the connections, and now will be shown only the specific connections related to this specific client, okay? As I said, there are also additional widgets, also providing us different kind of information. Let me erase that host. So for example, this widget is providing us the information of all the connections by their current state, also the total amount of connections by switch. Okay, so we can see which are the switches carrying the biggest amount of traffic in our network. We also have an histogram showing us at which moment these connections took place, right? And here down we have one by one every single connection that has traversed the fabric. Okay, so for example, same way as I did before, imagine that we are interested only on the connections made by this specific device, this specific client. So I will just click on this. Now this is drilling down the information, and here we have all those more than 8,000 connections one by one, so we can expand any of them, okay? And we have access to all the information related to that specific connection. So for example, the current state of the connection, when it was made, the destination host, the destination IP, the location, okay, the destination port, all the information that you can see here. Now, very quickly, the same way as I did creating a VLAN on the CLI, let me show you how it will be done via UNO. So we will just go to Manager, Layer 2, Manage VLAN. Here we will, okay, let me move to this fabric, the same one that I was using before. Now we will do a click on Create a VLAN by ID, okay? Select Switch All. We want this to exist in all the fabrics. So now let's create it. For example, the VLAN 231. The scope will be fabric. We provide a description. So VLAN 231, for example, and additional fields. We just click on Auto VXLAN and then provide an BNI identifier. So in this case, 1231. Click on Save. It's been created. Okay, and now let's take a look into that. So we can filter here, 231. Let's delete the switch. ID, the VLAN we just created. And here you can see how simple, just a few clicks, and this VLAN has been created and stretched across all the devices which are part of our fabric. Okay, this is all that I wanted to show you related to UNO. Let me stop sharing and back to you, Andy.
Back to me. Well, thank you. That was actually the last demo for today, because now we have to put it all together. So we talked about the needs of the cloud. We talked about the complexity, the fragmented. I'm back. Network connection coming back. Can you hear me, Noel?
Okay, you're back now. Yeah.
Yes, we can hear you.
It's always by, yeah, I've installed a new Vodafone wireless router here, so not blaming anyone. Okay, anyway, this is part of it, right? Resiliency is always good. Now we'll have to put it all together. We talked about the complexity and the fragmentation. We talked about what is kind of mandate for the network, but we've identified that is, you know, within the cloud, it's not the network is one player. We're getting into, because we're now extending the whole aspect of complexity and fragmentation to the compute side and to the server as well. So the same concepts around underlay, around fabrics, around a single entity of a network connectivity will be applied in our unified cloud network, cloud fabric vision and architecture. We are basically taking the knowledge and the skills from the server. We're taking that skill and we're placing it into the NIC cards. So what are the benefits and what are the migration aspects? You're running another vendor's network, third-party integration, I'd call it. Let's call it out. It's a Cisco network. It's an Arista network. But you're running DPUs, and on the DPUs, you might be running a Pluribus NVIDIA environment. We're able to kind of form a fabric over these DPUs within the network queue of your choice already. If you've got a second data center running Pluribus switches, we are able to easily and seamlessly integrating the switch nodes and the DPU nodes as a single entity. And then you've got that hybrid approach where basically within the same data center, you've got the switches, you've got the smart NICs, and you've got like other vendors' equipment as well. So again, the choice, the flexibility, the agility you can have here, and you have your SDN-automated experience going all along. It's these mixed environments which is making the whole story about DPUs so interesting, and the easy way to basically take a already starting from scratch here. Okay, why is that?
But we can hear you.
Yes.
I believe that Andy has some internet connection.
Back.
Right?
I'm back. I can hear you.
Very good.
I'm sorry.
Yes,
I
we
don't know
can
what's
hear.
happening. No, first time I was having these issues. So now this is basically where we're heading at. This is as of today. But then the beauty starts when we're talking about that fragmentation and about the complexity in regards of public and private cloud. Because within the roadmap, we have basically the solution to integrate our solution also into the public cloud, and you can stretch your own workloads into the Azure's and AWS environments as we speak today. So this is an offering. Other workloads and other tools are already using, and with SmartNICs we can make that use as well from the networking side. So then we're talking about a completely unified environment. It'll be stitching the private cloud with the public cloud, from the network to the server, into the DPUs. So this is kind of the vision we're embracing. Now, what are the true benefits going along? It's all automated, comprehensive networking, from one end to the other, with a much lower. We're reducing the complexity, we're reducing the OpEx costs, and we're eliminating errors, we're eliminating downtimes. We are having some key micro-segmentation use cases. You can segment your networks on the DPUs. You're able basically to run your firewall instances next to the fabric instances on the DPUs, and you'll have a true micro-segmentation, a fully secured environment without having the downside of being locked into a single vendor like VMware, because you're open. You can choose any other vendor's devices as well. Manuel showed around the visibility, and we're taking that visibility. We know what's going on into the DPUs. So you've got a full end-to-end telemetry data, which we are providing here, from the network into the server. We can record all the traffic and we can make it visible, and we can work with that traffic. It's basically the base of it. And last but not least, it's all around that open networking vision, not having to lock you into an environment as a customer, but being open and making sure you'll take the benefits of choosing your preferred networking vendor hardware. Right, and I think this is time for Q&A here. We're good in time. We're exactly like 10 minutes to 3. Łukasz?
Time is perfect. Time is perfect. So thank you, guys. And I was making some notes with the whole question. So let me maybe go one by one. Gentlemen, all is looking great. The question is how someone can play and put the hands on, especially on the DPUs. So this sounds really interesting, and how someone can get the hands on the software, make a trials and so on.
Yeah, I think, and I within my presentation, because I already talked about this, and I said it is available. So the NVIDIA Bluefield SmartNICs are available. Our code is available. I mean, the easiest way is contact us. Contact STORDIS Pluribus. We are able to run demos, and what we're doing is we're running so-called early field trials. So we've got around a dozen customers in Europe who are currently trying this out. We're providing the hardware on site, so we're basically getting them the Bluefield NVIDIA SmartNICs in order for them to test them together with us. Okay, so 2 ways: demo via us or sign up for the EFT Early Field Trial Program.
Absolutely, absolutely. Speaking of those, totally new approach, so putting your software on the smart NIC cards, we know that there is right now a really close cooperation between you guys and the NVIDIA. How do you see the roadmap or what needs to happen? So with the switches and the open networking, we know that always you have to go over some, call it, let's say, like a porting process. So to qualify a new platform, how that is looking from that NIC perspective, is that pretty similar?
I think we expect that to be pretty similar, right? We expect for us, obviously, NVIDIA is the first choice. We are partnering up. We're making our first steps together with NVIDIA. But just like with open networking, when we talked about Celestica, Dell, EdgeCore, hopefully we'll see other vendors emerge. Now, NVIDIA is by far the most advanced player in the SmartNICs environment. Well, we talked about AMD has now made some acquisitions. We know Intel is moving that way. And we also know that on the software side, there's a lot happening. So I think over the next 15 months, Lucas, we'll see a lot of traction. We'll see a lot of vendors basically moving into the SmartNICs, and it's pure innovation. The one who's gonna come first obviously has advantages, and this is where we're trying to be the leading edge player in this market.
So is there some kind of like a hardware compatibility list already between you and the NVIDIA, or we can say what you are qualifying from the NVIDIA side? The portfolio of the NVIDIA NICs is pretty wide, yeah?
So absolutely, there is a compatibility list. There is like only a supported list of SmartNICs, which is obviously been extended as we speak, okay? But to answer your question, I don't have it by heart here. I don't know it by heart, but there's definitely a list available to make sure. Which, and we're basically we can basically give advice which SmartNICs to use.
The next one, if I can, coming from the mark. So you describe it how you can stretch the Pluribus fabrics across multiple sites, effectively making the entire fabric behave like a one big switch. Do you have any Marcel, any European customers using that solution already?
Oh, we've got multiple. Yeah, thank you. I mean, we're using it in various use cases over multiple customers. Calling out a big public administration in Spain here. We've got a big bank in Italy. We've got Vodafone in Germany running on it. Actually, Telefonica is using it. I talked about the 100 mobile operators. So we know that with Orange, Telefonica, Deutsche Telekom, they are using that concept. So it is an established, mature environment. And we feel pretty confident that the concept itself, the fundament, the cloud fabric, has been proven in the field, and we're just taking it over into the on the SmartNIC.
And going again to the SmartNIC, who do you see as your competitors? I remember indeed when we've been discussing one day, there are some potential options on the horizon, but I know that you've been already working. How long it will be? 1 year, 2 years? So I see Pluribus as basically today like a leader. Yes. Any comment on that?
Yeah, well, definitely we are one of the first ones who have a working solution and a proven solution. I already called out one of the competitors, and this interesting wise that competitor had a very similar approach like ours, being open, but they've just been acquired. Pensando has been acquired by
AMD.
So, and the whole idea we're following up is being open, being not having to give our partners a lock-in. So here is basically where we're seeing our advantage. That yes, we are basically still maintaining and we're sticking to our vision around the open networking approach. Now we know that. Other vendors, we know that Sonic is going to go that way, but Sonic being in DevOps environment, open, we consider them to be like 6 to 9 months behind us. Because I think there's going to be a lot of movement, and I think within the next 9 to 12 months, you'll see a lot of vendors jumping that train and announcing. Most likely, the ecosystem is going to grow, but then having a mature solution already in place, that is one of the biggest benefits and advantages we can give you.
Perfect. Thank you. Maybe next one from the Chris. How the licensing is looking for those new smarts?
The licensing will be we will step away from a perpetual license to a as a service license. That one will be reflected back to the to your question around which SmartNICs will we support. So in the final rollout, obviously there will be different SmartNICs available with different bandwidth, with different speeds, with different capabilities, and hence the licensing on as a service model will kind of adopt to the hardware. So please expect kind of a bit of a change in the licensing. It will not have the perpetual one we'll have today, but it would be more or less as a service offering.
Excellent. Thank you. Let me check the
questions, by the way. Manuel, anything? I think I didn't miss out on anything here. Okay.
Yeah. Anything to add?
No, I think I'm good. We're good. Right.
I'm also checking that I believe that we are good and still basically on time. 2 minutes left. So, gentlemen, really appreciate. Always like a pleasure. Andy, Manuel, thank you for your time. Thank you also for those all the people who've been together with us live. Like always, if someone has any questions, would like to try, please feel free to just reach out directly to Pluribus or us locally here as a STORDIS, and we are more than happy to help. Once again, thank you, gentlemen.
Thank you.
Thank you for joining.
Take care. Bye-bye.